Here we go again, folks. Somebody that can measure something but has no idea how it works. And I'm even getting pushback from Chris Connaker. And let's dive into this. We got somebody that has, look, kudos for grabbing the cards, grabbing the scope, using the generator on the scope to input a signal and look at the output. But we are missing the forest for the trees, and I'm not the only one in this thread with questions and pointing out some obvious stuff. Some of the other problems that come in is the person that's doing this is, saying I've developed UPnP, I've done IP-based building control development, stuff like that. I'm an expert, and the problem is well, if you're an expert, you wouldn't be saying what you're saying as far as this. So they take several Intel cards. I use these throughout a lot of my builds just because you can get them on eBay for $18, and usually they're brand new pulls out of systems where they've upgraded probably higher speed or fiber. I also have the Intel 210, and I have a i350 card in my Dell servers, so I probably have most of this. I don't have any of this. I have Solar Flare when it comes to the 10 gig stuff. And we get back down to this. We are terminating into a ASUS Wi-Fi router, and he's using, I think, a 100 megahertz scope. And then he's got these two probes attached to the send and receive on a card doing 100 megabit. So the first point is he's doing 100 megabit. He's not doing 1 gig or 10 gig. That is a little bit of an issue because we want products that take advantage of as much wire speed and underlying hardware that would be buffering CPU bus bandwidth that we can. What we don't want to be on the line with data. We want to be on and off as quick as we can, which is also why, again, I am a big proponent of JRiver. JRiver allows you to build your own systems and use high-speed everything, and it'll take full advantage of that. And that comes into a question of caching. So what we're going through is I patterns on the card. So here's the dual 10 gig Intel NIC. There's its I pattern for 100 meg. Its rise and fall times on that. And remember, these are all 25 megahertz signals. And we get down to the super micro card, which is also a 10 gig card. And both I patterns are very good for data recovery without BER creeping up on us. Here's a good old trusty $18 Intel card, which is even cleaner than the previous two 10 gig cards. Again, everything is fine up to this point. Got our i350. That looks the cleanest of all. And we've got our 210. And finally our TP-Link, which, as long as our I is met and our I is in spec, all the surrounding stuff doesn't matter because we have read this into FIFO somewhere. And most likely we've read it to FIFO on the NIC, and it has done another copy upstream to some buffer set aside by the operating system, and probably yet again to some buffer set aside by the playback application, and then it's going to hit the USB bus, however that's handled. That's going to be packetized again on the USB timing. So the data, by the time that it's playing back, even in your dedicated streamer, when in this case he's using some KEF with built-in Ethernet, there's still going to be, it's still a computer. They're still going to do all the operations that define what a computer does as far as I/O. And the big back and forth, which, thanks for just cleaning all that up, Chris, because, we can't have anybody's ideas challenged, but it couldn't be left alone. So let's get into that. And as previously mentioned, I'm not the only one that's going to start pointing out some stuff, and Miska makes a really good point that a lot of these Intel NICs and higher end NICs do a ton of offloading, so your CPU doesn't have to do it. And here we go. And because no measurement method has yet managed to measure the differences on the analog side. It could be because there are no differences on the analog side. And I've gotten to this point again, and I'm basically, Chris is calling me condescending or argumentative, probably condescending. He honestly probably thinks I'm an asshole for digging in and sticking to a position. Playback, streaming playback, is not real time. You cannot sit there and say that you have pace, rhythm, attack, and timing, these improvements that are all in the analog real-time realm, to a digital paginated data delivery method. I had a YouTube video playing that played and it stopped. I went into my PRTG SNMP server and found out that my internet connection dropped 45 seconds prior. I was watching something for 45 seconds with no internet connection. This is just, this is horrible. And then when I do come up with a classical measurement method, which is everybody saying that they can hear this stuff, I'm going, we can take a network card. We can do 802 .3 AD, which is LACP, which is take two cards, treat them logically as one, and then we can remove connections without an interruption in play. And nobody will actually address that with me because they just know that they're going to get tore up when they do this. The amount of echo chamber and cognitive bias is just stunning. Miska is correctly pointing out that common mode noise does get canceled in Ethernet cabling. Ethernet cabling is a fully balanced differential signal. It's the entire point. It's why we can run something for 328 feet per spec, and usually you can get a good 380 out of it, 1 gig, without your BER creeping up on you, or FCS, or what have you. Let's touch on this for a second. Dang it. Fiber's going to be laser based. It's not going to transfer any electrical properties. And fiber most certainly can remove noise. If you've got some 60 hertz, 50 hertz hum down at 140 dB or negative 140 dB, it's not going to be there after it goes over fiber. It just can't ride over it. So again, just be willing to be corrected, accept it gracefully, don't argue it. It's not something up for debate. And here we have Miska back in asking all the right questions. All right. I agree with him here. I just think you use bog standard audio gear. Cisco, HP, MikroTik, seems to be popular. They all make well-engineered gear. He makes a good point about SFP slots, allowing you to, get various connections, fiber or, copper. I love this question. I'd like to see it answered. And he even gets in the point of 802.3 AZ, which is energy efficient Ethernet, EEE. And his last point, why would we use 100 base TX? And he has seen mostly ground link, PSU, and USB related problems. But what he's not seeing is Ethernet related problems. I've never seen them either. So Ethernet is a great solution for getting audio, and I have done it in live production broadcast with Ravenna and AVB. Again, Miska's making really good points. Same points I'm making is the faster we can transfer, the less transfer noise we have. And let's take this to a ridiculous example. 100 meg can do DSD 512, 2 channels, just fine. All right, so why not just use 100 meg? Or you can technically use gigabit and you get 10 times less wire time. You could use 10 gig and get 100 times less wire time, or we could go to 100 gigabit and we could have 1,000 times less wire time. So my point being is, let's say it's not even 100 gig. Let's say it's 1,000 gig. Let's say it's 10,000 gig. My point is we're getting to the point where when we're at that much throughput, the time spent on wire is almost coming down to the point that it's atomic. And that for a 8-minute song, we are talking just fractions of a fraction of a fraction of a second to get that data over if we want to be technical. And that's the point he's making here is, why wouldn't I just put as much wire speed into this as possible, get an entire audio track over in just fractions, again, fractions and fractions of a second, 0.999, 4 or 5 nines out, and just do it that way. And it's a perfectly good point. And he again wants to bring back up the point, any crosstalk is common mode signal, which is in turn canceled out in the differential receiver. The only thing that's not common mode is shielded cabling, because the shield has no differential to offset it, which is why we don't use shielded twisted pair. We use UTP cabling. And this is where I start, I don't consider myself trouble, but I do start getting in trouble because somebody doesn't like my tack. We've got somebody that later in the thread after this is starting to talk about how they're an expert, how they've designed UPnP, how they've designed IP, building automation controls, and then they come out with this gem. No, it's not a feature. It never came out with the 1,000 base T spec, but if you've been around 20 years and you did this shit 20 years ago, you know that 8023AZ is really 99% predominant 1,000 base TX standard. You go out right now, purchase 10 different vendor switches with gig networking on it, and have a really good shot at getting 8023AZ. You go out and pick up 10 random different vendors, 100 megabit switches, and I can almost guarantee you to the last one, you will not see the standard on it. And I do get in trouble later on this because I'm now calling this person out for not knowing what they're talking about. And Chris doesn't want to have it. And I don't know why. Chris, you run a site that is about where audio meets technology. If you're going to be a site where audio meets technology, then be a site where audio meets tech. And you can't have one without the other here. So he's going to move on from talking to an embedded Ethernet engineer to now to being an expert on his own. I guess make up your mind. I don't need to trot out the appeal to some anonymous authority on this. I can have these conversations natively in real time with anybody, and it'd be nice if you could do the same. He's specifically talking about streaming, and if you're streaming and you're 15 hops away, the last hop that matters is the last hop. That's it. The servers at Amazon, the servers at Apple, they only matter in that they give you access to the source material. The intervening routers don't matter. They're just there to make sure that they relay on the information. Everything is reconstructed per hop. And again, it is the last link that matters. And if he's an expert, then he should know what he's missing. And he's missing 8023 AZ. That's triple E. We are missing PoE because it'd be great to be able to put these endpoints, which I do with my Raspberry Pi 4s, all over the place with a breakout that just does a PoE split for me, and that's it. He should understand that we get a lot more throughput and less wire time. If you're an expert, you'd know all this. I've already made this point, but just highlight that we did it in the thread again. I'll give kudos where kudos are due, even to people that I really have disagreements with. And Alex makes a really good point just about the voltage levels for the different signaling rates, and that's fine. But then we get back down to this, which I don't agree with, and there's all sorts of ground plane noise going on in devices. Your job as a designer is to make sure you filter all that out and you sanitize your inputs. And unless there's a different paper than the white paper that they dropped probably about 2 years ago, and I would love to see these measurements, by the way. I don't think he's ever showing those. So that's indeed a problem. You can't sit there and talk about shit that you haven't produced, and you haven't produced this. I can read an eye pattern. I know what the eye pattern represents, and I know as long as the eye conforms to the standard, the data is successfully going to be extracted. And I also know that the eye pattern is not going to be 100% all the time on the wire. It's the entire point behind having a modern Ethernet system. And this is the same pushback that I did on hands, that you're making a demonstration where you fundamentally do not understand what you're talking about. We're talking about a 25 megahertz base clock that gets clock multiplied out to 125 megahertz. And my ask is, where are we hearing the harmonics of the fundamental 25 megahertz clock? Show me. Go onto your scope and show me any spike on any waveform where it's coming through. And you can't do it. And I'm not arguing with you that you've shown several different eye patterns. What I'm debating with you is how this relates to audibility, and it doesn't. And here's where we get into your claim that you think that you know what you're talking about. I point out that I'm not the only one pushing back. And Chris, I'm not being offensive, I'm being frustrated. What we can't have is we just can't have a conversation. That's what you're really getting at. You don't want any of these questions asked. I don't know why. Again, you run where tech and audio meet. You invite people to freely participate and bring their contributions and bring their expertise. And then when they bring it and they feel like they've got to just pound it through a thick skull to get the point home, and I'm not the only one in this thread, by the way, doing so, all of a sudden it's now offensive. You're rolling out the tar and feather words. The better way to do this is to actually push back against what I'm saying and prove me wrong. And my question is what way can we do this? I've already specified a really great way is to do 8023 AD LACP link aggregation. These are all Intel based cards. We can actually use the Intel teaming software for the adapter, and we can take a 540. We can take a 210 card. We can take one of the older Intel Pro dual port NICs. And we can team all these adapters into a link, aggregate it out of a switch, and actually swap them on a streaming device. And you can go eyes only, or sorry, ears only, because I'll trust your ears as much as you do. And if you'll sit down and do ears only evaluation, I will totally throw in, bring all the equipment to bear, and help make it happen. And we can even do it in your own setup, with your own material, in your own room. The only thing you will not know is what is actually playing back. That's it. It's a simple offer. Can't make it any simpler than that. And sorry that I've had to resort to yet another YouTube video, because we need to start having a conversation in the forum where I'm not going to start getting censored, because I've got such a pushback against what I think is just misinformation. Hope this has been helpful for people. It's a little bit frustrating for me, but it is a hobby. Nobody ever died. Thanks.